This is One-Dimensional Forces Quest Review, problems 8 and 9 involving horizontal motion. Lacking a puck, Sean and Brad decide to play ice hockey with a handy 2.3 kilogram rock. After Sean hits the rock, it moves 24.0 meters per second. Unfortunately, it slams into a snowbank and comes to a stop in 1.39 seconds. What was the average impact force on the bank? Okay, so initially looking at this and reading it, I decided VI was 0 because he hits the puck first, and VF was 24 meters per second. But then I have another VF of 0, so I've got a problem. What area am I really interested in, the beginning or the end? And it really is the end that I'm interested in. The time it takes to stop is 1.39 seconds. There's another issue because it asks what is the force of the puck on the bank. After doing the problem, they really want the force of the bank on the puck. But we'll work with that later. So right now I'm going to draw my free body diagram. I've got the hockey puck, and of course I have a force of gravity, and I have a normal force, so I'm going to draw those. And then I have the force of the bank stopping the puck. So this is after Sean hits it. So really the only force acting on the puck is the bank stopping it, which we could call an applied force, or we could call a force of friction, or we can call it the force of the bank on the puck. I'm going to start by summing my X and Y forces off to the side. On this problem, I did not show my Y forces, which you need to do on the test, so don't forget to do that on the test. Here, I'm just looking at my X forces. The only X force is the force of the bank on the puck, which is hard to write in a small corner. Now that doesn't really help me find F net, so I'm going to use F net equals ma, and I've got a mass, but I don't have the acceleration. So I'm going to have to use my kinematic equations to find the acceleration. And at this point, I've decided that VI equals 0 is just wrong, and I'm going to rewrite my whole problem. So now I've cleverly rewritten it, so VI is 24 and VF is 0, and I'm going to use the simple equation VF equals VI plus AT to find my acceleration. So VF is 0, VI 24, plus A times 1.39 seconds, and that gives me an acceleration of negative 17.266 meters per second squared. I take that acceleration and put it into F net equals mass times acceleration. The mass is 2.3 kilograms times the acceleration of negative 17.266, which gives me a net force of negative 39.71 newtons. Now it turns out this is not a well-written problem. The force of the bank on the puck is a negative 39.71 newtons. The force of the puck on the bank, thanks to Newton's third law, is a positive 39.71 newtons. But the answer they wanted in Moodle was negative. Next problem, Mike and Carl are playing a duet when a non-music lover comes over, grabs the sheet music, and hits it hard. Joshua catches it all on video. Going back and analyzing the video shows the velocity of the sheet music would be an impressive 38.7 meters per second after 0.049 seconds. The sheet music is 10.8 grams. What was the force of impact on the sheet music? We have to infer that when they're playing the music, the initial velocity was 0. And so that 38.7 meters per second is a final velocity, and the time it took to get to that was 0.049 seconds. The mass is 10.8 grams, which we changed to kilograms, moving it 3 places, not 2. So it's 0.0108 kilograms. And we're hunting for the applied force that was given to the music, or the force of impact. So again, we start with a free body diagram, the dot representing the music, and of course I have the person hitting it, the force of impact. That's a horizontal force. In addition to that force of impact, we also have the force of gravity on the music, and the music is flying through the air at this point, so there's really no normal force, but we're not going to analyze the Y forces. We're just going to look at the X forces. Remember on the test you need to analyze the Y forces too, not just the X. So in the horizontal direction, the net force is simply the force of impact F net equals ma, which isn't terribly helpful unless I have an acceleration. So I'm going to use my kinematic equations to find the acceleration. I'm going to use a simple one, Vf equals Vi plus At. My Vf is at 38.7, my Vi is 0, my acceleration is what I'm hunting for, and the time, of course, is 0.049 seconds. Doing all that in the calculator, I get an acceleration of 789.796 meters per second squared, an impressively fast acceleration. So the F net is going to be mass times acceleration. Again, my mass is 0.0108 kilograms. My acceleration is at a very large number, 789.796. And when I multiply them together, I get a net force of 8.53 newtons. That is the end of the problem and the end of the video. Thank you very much for your time.